So let us now discuss about classification of signals. The first classification is continuous time and discrete time. So signals can be classified as continuous time and discrete time. As the name itself says, continuous time signals are those which are defined for all the time. For example, this is an example for continuous time signal. So as you can see, the signal is defined for all the values of time starting from minus infinity to plus infinity. In fact, even this signal is also a continuous time signal. This looks like a square wave signal. It is a continuous time signal because the signal is defined at all the time. The value of the signal at this point is defined to be equal to 0, and at this point it will be some value, say equal to say a. So which means for all the values of time the signal is defined. So such signals are called continuous time signals. Um Coming to discrete time signals, as the name itself says, discrete time signals are those which are defined at specific intervals. They are defined only at specified intervals. For example, this is an example of a discrete time signal. So as you can see, uh, the notation that we normally use is x n. So it is defined at regular intervals 0, 1, 2, minus 1, minus 2. Whereas at these points in between, it is undefined. So such signals are called discrete time signals. Now the next question is, how do I convert an analog signal into a discrete time signal? The process of converting an analog signal into a discrete time signal is called sampling. So this process is called sampling, and it can be represented by using a simple equation as follows. So let me just assume that x of t is the signal, and sampling means at regular intervals of time, say t, you need to sample the signal. So the signal is represented as x of nt, and after discretization, it can be represented by using uh, x n. So here the value of n will be 0. It can be plus or minus 1, plus or minus 2, etc. So this is how a continuous time signal can be converted into a discrete signal x of n, and the process is called sampling. So let us just take an example. I'll just take a sinusoidal signal, say x of t is equal to, the amplitude is 2 sine 100 pi t. This is a continuous time signal. Uh, you can even calculate the frequency also, as this is omega naught. So omega naught is equal to 100 pi. So you know omega naught can be written as 2 pi f naught. It is equal to 100 pi. So pi pi cancels. So f naught is equal to 100 by 2. That means it is 50. Which means the time period t is 1 over f naught. given by 1 by 50. So it is a sinusoidal signal with frequency 50 Hertz or uh, angular frequency 100 pi. Now if I want to sample this signal, let me assume that I am sampling at regular intervals, say 0.01. Therefore, the sampled signal can be written as x of n times t, and that is equal to x of capital N, sorry, x of n. So x of n can be written as 2 times sine 100 pi. Now t is replaced by n into capital T. So this can be written as 2 sine 100 pi into n times t is 0.01. So it is 2 sine 100 into 0.01 is 1. So it is 2 sine n pi. So this is the discrete version of the signal x of t, and you can calculate for all the values of n, say value of n and value of x of n. For example, if n is 0, when I substitute n is equal to 0, it is sine 0, sine 0 is 0, so the value of the signal is 0. When n is equal to 1, so it is sine pi is 0, the signal is 0. When n is equal to 2, uh, sine 2 pi is 0, therefore the signal is 0. So you can notice that for all the values, the value here continues to be 0. So what actually happens is a sinusoidal signal. You should notice one very important thing here. So I have a sinusoidal signal, and its time period is 1 by 50. So 1 by 50, you can just calculate, it will be 1 by 50 is uh, 0.02. Okay, so when I plot this signal, sine, so that is the period is 0.02. So this is one half cycle. Uh, so this is how it is. So this is 0. One period is 0.02. It means this is at 0.01. This is at 0.02, etc. So you can notice that since my sampling period here is t is equal to 0.01, I will be taking one sample here, which is 0. Next sample is at 0.01, which is again 0. Next sample is at 0.02, which is again 0. So what you notice is all the values are zeros. So your signal now will be 0, 0, 0, 0. So the sample signal will have all the values equal to 0 for this particular case. So now what I want you to do is, I'll give you two signals. X of t is equal to, say, some 5 sine 50 pi t. I want you to sample this and write the values of x of n for sampling period t is equal to 0.01. Okay, this is the first problem. The Next problem, you can just take a signal, say x of t is equal to say some 100 times t for t between 0 to 10 seconds, and it is equal to 0 otherwise. So in this case, I want you to sample at a value t equal to uh, say about 0.5 seconds. Okay, so in both these cases, uh, what is x of n?